Good afternoon and welcome everyone to today's webinar with Steve Hutt from UAVionix. We're delighted to be able to welcome Steve today. He is going to be talking about delivering UAS BVLOS flight in non-segregated airspace using aviation grade command and control. With masses of experience from a number of years, Steve offers experience from both the States and working here in the UK too. And we are delighted that he is able here to share some of the information that has been going on and to take us forward through this presentation. Steve, do you want to share your screen? And I will then duck out essentially so that you can take over. That's great.
Okay.
I'll stop my video there. There we go. Over to you, Steve.
Okay, thank you very much, Eleanor. So yes, thank you all. Good afternoon. Nice to be here with you. This presentation, the webinar, sort of skyline that's on, you can see on the screen now, is a thread going through that. In fact, skyline and standards are the main three themes running through this. The presentation contains a lot of information. I'm not going to go through every single element of it. This is to give you a taster. My theory is that if you want to read all of the detail in the presentation, you'll be able to review it through the recordings. Okay, so that's the idea behind it. So please don't feel that you haven't got a chance to read everything, because you'll have to go back and look at the recordings. So I'd like to thank Eleanor and ARPAS for offering us the opportunity to give this presentation and webinar. As Eleanor said, my name is Steve Hutt. I work for UAVionix in the UK, and the presentation is about delivering UAS BVLOS flight in non-segregated airspace using aviation-grade command and control. So I'm hoping that a good many of you will be familiar with UAVionix. We develop and design and manufacture low swap, low size, weight and power avionics. We provide those on a sort of global basis to manned aviation, to the UAV and UAS communities, to airports and air navigation service providers, ANSPs, that sort of thing. We have a strong focus on standards and delivering technology that meets standards. We've in the manned field, we have over 22 TSOs, type certification orders, and supplementary type certifications and other associated certifications. And some of those, like the Ping 200X transponder and the TrueFix GPS, are examples where we've been able to take over those aviation certifications from manned aviation into the UAV world. So we're providing increasing amounts of technology to the UAV world, which is certified to aviation standards. These standards and certifications are recognized by the FAA, the CAA, the EASA, and various aviation regulators around the world. UAVionix has got a heavy background in aviation. A good proportion of our employees basically have pilots' licenses, so they're deeply embedded in aviation. So the aviation standards that exist today for traditional aviation are a basis for everything that we do. Those aviation standards have been used to drive the developments in air traffic management that we're familiar with, and communications, navigation, and surveillance is the focus of UAVionix. As I mentioned earlier on, some of those standards can be leveraged in the BVLOS UAS world. Some of them are still emerging and developing, and we're going to touch on some of those today. But the idea is that by having recognized standards, it enables the systems to develop and and share information much more easily. So this presentation is going to go into command and control, colloquially known as C2, and surveillance based on ADS-B and radar and optical. The integration of these systems is driving towards some commonality between the ATM world and the UAS world. So in traditional aviation, you have air traffic management services, and the communication, navigation, and surveillance CNS services are provided to those operators in order to make that system work. Those standards are increasingly performance-based, and there's also a drive for international harmonization. That has a bearing on BVLOS and airspace use. As I'm sure most of you will be well aware, the norm today for BVLOS operations is that they are in segregated airspace, but that is slowly starting to change. So moving on to Skyline. Skyline is in fact the first real cloud-based command and control network. It combines a fleet management network, health monitoring, and detect avoid services. It utilizes effectively like a mesh network of radios, and the UAV can move from one ground radio to another with a make before break roaming sort of approach. It's basically purpose built for BVLOS. The components of Skyline are the ground radios, the airborne radios on the UAV, and the Skyline cloud system that links it all together. So before I go into more depth on Skyline, I just wanted to share with you some of the recent milestones that we've achieved at UAVionix using this technology. Back in July, we had the first ever BVLOS flight in the US using our C-band radios, which is an aviation protected frequency radio. This took place in Oklahoma and was using one of the US UAV test sites called Choctaw Nation of Oklahoma, and was utilizing the ground infrastructure. We worked with them to set up and using our C-band radios. This first particular flight was on the 12th of July. It was a 50-kilometer flight, and it was there was no visual observers. It was all done through the system, so with a remote pilot in command and a mission coordinator and electronic observer. This was all done under a waiver, which I'll go into a little bit more detail about waivers versus exemptions later on. But as you can see on the screen there, that's one of the screenshots out of Skyline, which is showing the flight, the blue line. It's showing the ground radios and the connectivity between them. On the left, you get information being shared back about the status of the system, and also on the right you can see individual details of the ground receivers and transmitters and the airborne receivers. So Skyline actually records the flights as well. So you see this sort of presentation in real time, but afterwards you can go back and review. And so the blue dots across the bottom timeline are showing when the communications roam from one ground station to the next. So it's a really good system for being able to not just fly the flights in the first place, but also to have a capture of what went on and to see where the flight went and how the comms were at any given time. This one doesn't show it, this particular snapshot, but even other traffic that flies by and is detected in the DAA system shows on the screen, and that traffic is recorded as part of the recording as well. So you can see that passing traffic in the recording. The exemption I've alluded to was just last week and a half ago now, 6th of September. The FAA granted the UAVionix an exemption to enabling us to do BVLOS flights, true BVLOS flights in the non-segregated airspace over North Dakota, in coordination with the Vantis network, which utilizes a lot of our technology for C2 and DAA, detect and avoid. Yes, so that the exemption is an important development, basically, and we'll come back to that shortly. Another recent one, again, from this time from the 7th of September, UAVionix has partnered with Iris Automation, and we are going to be bringing in optical detection into the DAA side of Skyline as well. So we've already got radar and ADS-B, and optical is coming to the system too. We've got a fair number of people using the system now. I mean, one key customer is NASA, which is using Skyline at their advanced air mobility test range. So they are looking to do R&D using our system for ATC and command and control for advanced air mobility. So that we're pleased to be working with NASA. We've got Skyline is implemented in a range of other sites across the US and the world, for that matter. Here's a list of some of the US ones. The FAA have got a program called Beyond, which is part of their UAS test regime, and some of these sites are members of the Beyond program. There's a Canadian one listed there as well, using our system, but we've also got sites in Europe and Asia as well using the system. An even more recent one, this one was from the 14th of September. Kongsberg Geospatial are going to integrate our Flightline TrueSky ADS-B system into their Iris terminal, which is it's an airspace visualization tool for UAS, enabling their customers to use electronic observers as well for BVLOS. And finally, here the last example is some work we did back in June in the UK, and working with our friends at BT and Skylift. We flew using the same technologies here in the UK at the BT's test site in Suffolk. In fact, we achieved two UK firsts with this. So this was the first use in the UK of the Skyline system using both the C-band aeronautical frequency and BT's drone SIM in our radio. So it was a dual data link C2 environment, and we also was the first use in the UK of 978 megahertz ADS-B from a drone, which we're going to be talking about a little bit later on as well. And in this particular setup, the BT have got a building about 10 or 12 kilometers from the test site, and one of the radios, the ground radios, was set up on there, and others were at the test site. So it was the drone was able to roam between the local and the remote ground radios as well there. So yeah, so it's not just in the US. This has already been starting to be used in the UK. Excuse me. Coming back to the the FAA grant of exemption. What's key about this is that the FAA basically were looking to advance their rulemaking for BVLOS, and they basically put out for public comment 4 requests for exemptions, and ours was one of them, and this was granted. And the key thing is, so there was people like Zipline, for example, or other ones that got exemptions. The UAVionix exemption is is subtly different in that the exemption covers the ground infrastructure as a key part of the exemption enabling the BVLOS flights. And the exemption was in fact enables us to carry on developing and enhancing our C2 and detect and avoid capabilities within the Vantis setup in North Dakota. An exemption, people might have been used to the term waiver used in the US, and waivers are basically a one-off approval, which basically expire, and if somebody wants to do another waiver, you have to start from scratch. Exemptions are different. Exemptions are repeatable. They are technically part of the FAA's rulemaking regime, and other people can reference and effectively seek to build on the exemptions that have been granted. So these 4 exemptions that have been granted, including ours, are really key. It basically proves that the regulator, in this case the FAA, was happy with BVLOS operations using the setups that we have in North Dakota. So it's a pretty key step forward in terms of enabling BVLOS. So moving on to how Skyline is used, Skyline fits into a way of working called a C2 communication service provider. So basically, just as in traditional aviation, where there are shared services to deliver the air traffic management, in the C2 CSP, the command and control communication service provider, the command and control is a service that is shared by a number of different operators. So it basically means that the infrastructure on the ground can be set up to a very high standard. It can offer a high performance and risk-based approach to comms, which are essential for BVLOS flights. And it means that the flight operator don't have to provide all of their own ground infrastructure, because they can sit in their flying using a service provider. For example, the way BT is considering using the system, where you do not have to provide, the flight operator does not have to provide their own ground infrastructure. Under the Skyline system, I mentioned standards being a key theme of all of this. Control and non-payload communication is the service the system provides. As you can see there, it's got some definitive documents: RTCA DO362A and FAA TSO C213A. Basically set out the control and non-payload communications link systems requirements. These focus on critical safety of life information transfer. So this is not for payload use. It is enabling the regulator to ensure that the UAV is flown in a safe manner that does not incur or introduce risks. As we saw earlier on, the CNPC has an airborne radio system and a ground radio system. So those concepts are actually written into the standards, and basically, dictates how we have developed our system. In the C-band arena, this is operating on aviation protective frequency, which is another key feature of the system, enabling the regulator to be satisfied with the performance. And being on the aviation protective frequency, it basically helps to ensure minimal interference. The actual frequencies themselves is 5030 to 5091 megahertz, and there's a number of channels within there, a bit like in aviation. An airport has its own frequency, so you move to the frequency that you need to use. There's some. I'm not going to talk through this one too much, but basically, I've extracted some of the language used in the DO362 MOPS that describes how or what the purpose of the system is. But again, safety of flight and safety of life is the key feature here. Just for the record, I've listed some of the other regulatory documentation. So 362 we've talked about. DO377 is the minimum aviation system performance standards for C2. For unmanned systems, there's the TSO I mentioned, and also because we're into spectrum regulations as well. So there's a notice of proposed rule making in the US with the FCC that covers that C-band 503 out of 5091. Discussions are already underway with the CAA and Ofcom in this country around those same frequencies here too. So I don't want to teach people to suck eggs. I'm sure you're familiar with the sort of use cases that BVLOS helps to deliver function for, but these are the sort of things that I'm sure many of you will be already considering and working towards. So we talked about C2 CSP and multiple data links. So C-band is the aviation protected one, but our system, the Skyline system, can provide that C2 over a number of different data links. So it can use the mobile LTE, which we've done LTE and C-band we did with the BT Skylift flights. We've also integrated ISM, but that is using the US 915 megahertz frequency. So it's slightly different from the UK. And we've also already got SATCOM integrated. So in the C2 communication service provider model, you've basically got the ability to provide command and control to a drone through any and all of these simultaneously. And so unless you lose all of them, you basically mitigate the risk of losing the C2 by having multiple data links. In the C2 CSP model, again, you've got that shared C2 infrastructure and frequency allocation and then monitoring function. So it's basically looking to deliver highly assured command and control. So where we've got a single data link, we're looking to provide path diversity. So the one drone has got multiple ground radios it can talk to, and the path diversity exists by being able to have choose from multiple physical paths to its destination. And this can be, having a second radio on board can help with that. But the more important scenario is where you've got a second radio of the same type on board, I should say, in this instance. But you've also got multiple ground radios as well. And the mesh means that the drone can move from one ground radio to the next. As a consequence, because it can, if one of them goes down, you can migrate to a roam to another. So you end up with effectively a self-healing network. But then you can then overlay frequency diversity over the top of this. So that same diversity of path can be accomplished in a second dimension where you've got the ability to connect to multiple data links. So whether it be C-band, LTE, SATCOM, for example, which again just pushes up the level of assurance for the command and control. So moving on, this we saw a picture similar to this before. Basically, in the Skyline system, it's providing that sort of BVLOS radio C2 assurance from a centralized managed C2 CSP command and control infrastructure. As I said before, you've got information, and this one is actually showing, you can see some of the traffic from the DAA side of things being fed into the system too. So you've got information and status reports on the connection, the link connection to the drone and the ground station, and also you can see the traffic nearby. In the UK, electronic conspicuity is a key focus. Well, in fact, it's a key focus around the world. But in the UK, the CAA has been working to develop their approach for introducing UAVs into the airspace. And ADS-B, hopefully many of you will be familiar with, um, and typically today in manned aviation in the UK, that operates on 1090 megahertz. There is a second version of ADS, or a second frequency rather, that ADS-B functions on, which is 978 megahertz, which is already, in fact, has been used for years in the US. And the CAA and the DFT have basically decided to introduce the use of 978 megahertz ADS-B for BVLOS UAVs in the UK. That ruling and policies is not yet fully completed. There's still a little bit more work to do, but the basic model is that crewed aviation would use 1090 megahertz ADS-B out. The BVLOS UAS would use 978 megahertz ADS-B out. Both crewed, manned aviation and UAS has the ability to have ADS-B in receiving both of those frequencies. And so the fact that manned and unmanned are on different frequencies is neither here nor there, because the receivers are dual frequency. Another feature of the CAA's airspace modernization policy is to introduce a concept, what I call BVLOS airspace, basically ADS-B mandatory zones. So this is airspace that, in effect, you're not allowed to fly in unless you are outputting ADS-B. The consequence of that is that you achieve an ADS-B based known environment, and you can see all operators flying in that airspace. So in an ADS-B mandatory zone, you wouldn't need necessarily to have some of the other. So the terminology around this is basically people with ADS-B and electronic conspicuity are termed as being cooperative traffic, and without that you're non-cooperative. So for the non-cooperative, you would need radar and, for example, the optical systems in order to detect them. So where you have ADS-B mandatory zones, then that known environment can be established just with ADS-B receivers. As an aside, 978 megahertz also has a whole bunch of other services on it, which are colloquially termed UAT. So things like flight information service broadcast and traffic information service broadcast. And the CIA airspace modernization strategy is seeking to introduce those into the UK as well. Again, FISB and TISB are, and UAT in general, are long established technologies that have been in use in the US. And so the idea is that the CA is looking to leverage those existing technologies within the UK. So here's another representation of that. So GA on the left, ADS-B out on 1090, and ADS-B in on 978 and 1090. Manned aircraft in the middle, 978 ADS-B out, 978 and 1090 ADS-B in, and also supplemented by ground surveillance of ADS-B and radar and optical in where merited. The commercial side on the right is basically the same as the GA side. So here's a graphic showing the Skyline system. And so we have ADS-B receivers, ground receivers on the left feeding in traffic. We have where it's required and was used in the North Dakota and Choctaw Nation of Oklahoma test sites. There was primary radar feeding in as well to the detect and avoid system, with the addition of optical integration, optical detection systems being integrated as well, coming into the system. So all of this feeds into Skyline, meaning that the remote pilot and his electronic observer having access to all of this information as part of their command and control and their detect and avoid services that they're using to actually fly their drone in BVLOS. So, in summary, we have the situation where we've reached the point we can show to regulators to a degree that satisfies their requirements to approve BVLOS flights in non-segregated airspace. That is effectively what the exemption has done. The communications, surveillance, and navigation integrity is a key element of that. If you can't guarantee that, then that's one of the things that the regulator is looking for, is to ensure that is there. The performance and risk-based approach is essential. We've got the ability to leverage multiple data link types to give us the assurance that we need to maintain the command and control, whether it be over C-band or mobile or SATCOM. They're all there and able to be delivered through the same systems, and basically the autopilot on the drone doesn't know or care how the C2 information is being shared back and forth with it. And then the development of the command and control communication service provider model with that safety of life grade CMPC C2 is basically going to become a strategic enabler for BVLOS UAS ops, where you are enabling the scaling of that system by shared ground infrastructure for C2, rather than each UAV operator having to deliver his own independent command and control, which, as you're looking to fly longer and longer flights, is just going to become unwieldy for individual operators to provide that. So being able to rely on a service provision, just as traditional aviation has done for years, is basically one of the key enablers for the BVLOS. From an airspace point of view, we've already shown the use of non-segregated airspace with radar and with ADS-B in the States. That setup would work just the same in the UK, where the ADS-B mandatory zones, ADS-B TMZs come in, helps to simplify that. It shifts where the cost goes. You don't necessarily need radar in that scenario, but without the ADS-B mandatory zones, then radar and optical are going to be additional enablers that need to be there on the ground to support the cooperative traffic. So that was very fast. Hopefully it all made sense. Like I say, there's lots of information there that you can go back and review on the recordings. But that's the end of my presentation. Eleanor, I've not really kept tabs on the time. Hopefully I'm within the time frame you were looking for.
Very much so indeed, Steve. Thank you very much indeed. That was absolutely fascinating. So yes, absolutely. As you can see there, Steve's provided his email address as well as details about the UAVionix website too, if anyone wants to explore further on this. We've obviously now got time for questions and from Steve answers. So please do take advantage of having such a wonderful resource here ready at hand to answer your burning questions on this topic. There is, as Steve said, a lot of information to take in here. So I will be sending out after the event the Watch Again link so that you can catch up with it again. It'll be available also on our website and on our YouTube channel too. But in the meantime, steve.hutt with 2 T's at uavionix.com is Steve's contact details. Steve, do you want to just stop sharing so that we can have this conversation sort of more directly? There we go. Thank you. Well, I have to say, I was extremely impressed with everything that's been going on, both in the UK and the US side of things here, and that certainly has provided a lot of detail to work through. And I know, despite the fact I'm watching it here now, I'll be going back and rewatching it myself. So thank you very much indeed for providing such a wealth of information. Do we have any questions from the floor? Well, from our attendees? If you think you know everything, that's great. We're delighted. And in which case, Steve has provided both clear and sensible direction. But please do take full advantage of this time, because that's why we put these webinars on, to be able to share information and help everyone along the way towards a drone industry that is comprehensive, safe, and secure.
I can see what a little one in the red box in the chat. I'm not sure how to pull that up, but maybe there's a question there.
I think that was me reminding people to add questions via the Q&A link. That's where that is at the moment, I think. Yeah, that's right.
Can we just ask people if they understood it, if it all made sense? Perhaps we can ask them questions, maybe.
Yeah, absolutely. So, do you feel it made sense, everyone? Do please sort of add in if there's anything else you'd like to know a bit more about. We do have our first question, which is, hi, Steve. ADS-B TMZs, ADS-B positioning information comes from airborne GPS. Is that good enough to enable DAA, detect and avoid? Or do you think other systems / infrastructure is required to verify that position info?
The GPS information from ADS-B, I think I mentioned right at the outset that the TrueFix GPS that we make, for example, for drones, is actually Aviation certified. So there is a whole load of regulation around GPS. There's lots and lots of different status things, like source integrity level, which basically the higher the grade of the GPS and the more accurate it is, the better the information and the higher. So, for example, certified GPSs have a source integrity level of 2 or 3, and in some scenarios in aviation, you have to have a SIL 2 or SIL 3 GPS in order to fly in certain bits of airspace. There's so GPS regulations using high-grade GPS, not just the cheapo ones you buy off the internet, is part of all of that. Clearly, GPS jamming is an issue, and GPS jammers are available. So there are some concerns around GPS. At the end of the day, it's going to be down to the CAA to decide those ADS-B mandatory zones. So the process for ADS-B mandatory zones is that basically an operator or an airspace navigation service provider would apply, an airport or whoever would apply for an airspace change, and one of the criteria they would seek would be to implement an ADS-B mandatory zone. So it's not a quick process. ACPs, as I'm sure some of the folks on this call will know, can take a while. So bottom line is that the CA do not create ACPs. It's down to people to ask for them and prove the requirement. So ACPs with ADS-B TMZs are part of the toolkit that the CA is looking to enable for the drone industry. And as I mentioned, one of the challenges here is where you spend your money. So if you don't have ADS-B mandatory zones, then you do need to have a more expensive ground infrastructure with radar and optical and what have you. Luckily, the ADS-B receivers are relatively cheap on the ground, so we supply those. I think called a Ping Station 3, and the Flightline service we have as well do that. So it's going to be horses for courses a bit with different locations as to what infrastructure they set up and how much it can rely on ADS-B.
Thank you very much. That's a very comprehensive answer to that question. Thank you. Right. I know we have a number of people here from different parts of the industry, so I'm delighted to see that. Our next question comes from Matt. Much of the issues regarding integration with GA have stemmed from a cultural GA reluctance to be electronically conspicuous. While ADS-B works for us in TMZs, what has the regulator said about a future requirement for all aviation to utilise electronic conspicuity and hence negate the need for TMZs?
So the what you will be able to do is Google a CAA DFT joint statement on a new standard for electronic conspicuity, and what you'll find there is that whereas in the past the CAA and DFT have been a little bit, let's say, fair, they have now basically nailed their colours to the mast and said ADS-B is what they want people to use. They're not going to stop people using the other unregulated conspicuity solutions in GA, but they have very definitively said that ADS-B is their preferred EC solution. The CAA are not looking, at least at this stage, to my knowledge, to mandate general aviation airframes, but so they're taking that airspace approach. Mandating ADS-B in certain airspaces is the approach that they are looking to follow. What we do not know is how widespread those ADS-B mandatory zones, ADS-B TMZs would be. That's something that we'll have to see how that evolves over time.
Okay, very interesting. Thank you. Lovely. That's all the questions we've got for at the moment. Please do ask more. In the meantime, I'm going to tell you a little bit more about upcoming ARPAS-UK webinars as well. We have the next one is on October 10th and is being hosted by the National Protective Security Authority. And the subject matter is data security for infrastructure projects. This is a webinar only for ARPAS-UK members and RICS members. So if you would like to attend, please do join. You'll be more than welcome. After that, on the same week, on October 12th, we have Altitude Angel and Copters who will be talking about achieving safer skies, enhancing safety and visibility in drone operations. On November 9th, we have ARPAS-UK's own CEO, Annalise Scalieras, talking about SORA, an introduction to SORA risk assessment methodology for the specific category. So that will be a fascinating talk for everyone going forward. Again, that one is for ARPAS-UK members only. So again, please, if you do want to attend it and you're not a member already, do join. We have further CPDs coming up in November as well. We have the University of Portsmouth with Airborne Robotics talking about Dr. Suit, their project, which is about the inspection of offshore wind turbines by using drone swarms. It's been a project that's been funded by the Future Flight Challenge, and we're much looking forward to finding out more about that too. There'll be further ones after that too as well in due course. So we're just finalising the details on those at the moment. You're always most welcome. And I'm going to add in here also a plug for DroneX, which is happening next week on the 26th and 27th of September at Excel, and will be a very, very good place to come and meet people. I know Steve is going to be there himself. We shall be there too, as alongside a number of other ARPAS-UK members and others from within the drone industry. Tickets are free, so please do check out droneexpo.co.uk and come along and say hello. So we have another question through, which is Skyline only available in the United States? If not, how does one go about getting it?
Talk to me.
Steve.Hutt at uavionix.com.
Yes, that's right. Yes. Yeah,
Great.
as per the BT example. So there's the technology and then there's the implementation of it. So BT are looking to implement it, and other people can too. So
Great. That's a really good overview. Well, thank you very much. I'm going to give everyone the last 30 seconds or so to ask any last burning questions. But thank you very much indeed, Steve, for coming along. I will cease recording this in a moment, and then this afternoon we'll upload it to the website and send it through to everyone again as a recording link. Just to remind everyone, Steve's contact details are steve.hutt, that's with 2 T's, at UAVionix.com, and he will be at Drone Expo next week as well. So do take the opportunity to come and speak to him in person. Well, no more questions through, so I'm going to leave it there for the moment and give everyone sort of 15 minutes back of their lunch break and say thank you very much indeed, Steve. That was a fascinating talk. I'm looking forward to it already, rewatching it again and absorbing. There's an awful lot of detail there, and it's not an area I am totally au fait with. So thank you very much indeed. I'll look forward to seeing you next week, and take care, everyone else. That was great. Thanks very much then. Goodbye.
thanks, Eleanor. Bye.